analysis of that regulation. If they want to build a public project in some area, they have to, do a benefit cost analysis of the value of building it there. But the same basic methodology can be applied not just to these sort of public projects or regulations, but to assessing externalities. So, for example, determining what the correct level of Pigouvian tax is requires you to add up all the marginal costs and benefits associated with the activity to figure out what the overall marginal harm is, what the overall real externality is, so this can be charged as the Pigouvian tax. If you want to assess in a court case how much damage was caused by some negligence that was taken, which we said is another way of instituting Pigouvian damages, economists are often called in to do a benefit cost analysis of whatever the action that was taken that caused the harms was to determine the correct amount of the externality. Similarly, to determine the right level for cap and trade policies, you need to do an analysis of what are the benefits and costs of doing more or less of the activity. These analyses are done usually by a combination of academics doing, research in consulting capacities, by bureaucracies which hire economists within, various different administrations or regulatory agencies, and by the courts reviewing them to make sure that they meet the correct standards. Now, one crucial aspect in, doing these types of analyses is technical. It's really what are the physical harms and benefits that just physically follow from the actions that were taken. And this typically requires a detailed knowledge of a variety of sciences, including, for example, physics. So if you want to figure out what are the chances of a nuclear reactor spilling over and destroying the area around the nuclear reactor, you need to know what's the physics of a nuclear reactor. And so that the optimal tax or subsidy to put on nuclear energy is going to depend on doing that sort of scientific analysis. Another example is, I don't know if anyone knows about CERN, but this is this giant new particle accelerator that they built in Switzerland. And there are, sort of some lunatic fringe who thinks that there's a large chance that this is going to rip the universe a new one, as someone put it on a website, because they're doing things that are so high energy that it's possible that it'll create some tear in the fabric of space-time or something, just blow up the whole universe, right? So, knowing some physics is quite useful to figuring out what the chances of that happening are, and therefore what the externalities of creating CERN are. Chemistry can be quite useful as well. So, if it's very useful to know atmospheric chemistry to know whether sulfur dioxide emissions are likely to cause acid rain. Or what will the effect of pollution be on the chemistry of a lake? Will it cause it to become so nasty that no fish can live there, or will it, will the lake be able to cope with it? Epidemiology can be really important as well. So if you want to know what is the benefits to other people of me getting a vaccine, and therefore how much subsidy we should put on vaccine, you need to know what's the chance of me, if I get the disease, transmitting it to other people. Ecology can be useful as well. So you might want to know how the fish stock levels are affected by pollution or by overfishing in order to know what the externalities created by those are. Okay. Or what the ecosystem services values of a particular forest are to figure out whether deforestation is likely to be very harmful. But while all that's important, it's completely useless unless there's an economic analysis that's added on top of the scientific analysis. So, for example, the Fukushima Daiichi explosion caused an enormous amount of harm. And knowing the physics of nuclear explosions, nuclear meltdowns would be really useful in preventing that sort of thing in the future and trying to figure out how much damage it will cause. But unless we can put an economic number on how much that is, it's really hard to make trade-offs of that against other things. We need to know the value of the land that was destroyed, how much the value of that land went down after the disaster. Acid rain, chemistry will tell us a lot about how much acid rain will occur, but it won't tell us how valuable are the crops that are destroyed by the acid rain. You know, if there's a possibility of some catastrophic outcome happening, like the universe getting ripped a new one, we have to figure out how we should put value on really low probability but really terrible events, right? And expected utility theory helps us think about those things. If we want to figure out how do we discount the future value of reduced numbers of fish versus the pollution value of polluting today, we need to think about intertemporal trade-offs, right? When we think about ecosystem services and what their value is, we need to think of the chance of a discovery of a new medicine, say, based on some animal living in some forest, and figure out what are the profits that will create and what spillovers those will have in terms of consumer surplus. So, similarly, when we think about how much value there is for me getting a vaccine because I might transmit a disease to someone else, we need to think not just about the chance of the disease spreading, but how much it hurts the other person that they get the disease from me, right? And we'll talk more about that in just a moment. So almost every useful analysis for public policy of these things is going to combine a detailed knowledge of the relevant science to get some of the facts straight, but also a detailed economic analysis to tie that to the actual values associated. So perhaps the most famous economic input into these types of analyses has to do with the value of human life. And this is quite a controversial topic because a lot of people say things like human life is, invaluable. There's just no way to put a number on how much human life is worth. But clearly, anyone who drives a car doesn't think that. So anytime you get into the car, you basically take your life into your hands. And I'm sure most people have at some point in their life driven a bit further in order to save a few dollars on something, right? And anytime you do that, you're obviously showing that you don't value your life in an infinite amount, because if you did, you wouldn't drive any more in order to save any money, right? And the society has to face the same trade-off, right? We could take actions that might make the society incredibly poor, but might save one person's life, or have some chance of saving one person's life. But that doesn't seem like a very good trade-off, right? So in our individual lives and in our lives as a society, we have to make trade-offs about human life versus other economic resources. And one thing that that's going to imply is that the wealthy are going to be willing to spend more to try to stay alive and on their safety than are other people, right? So like a rich person would be much less likely to drive to try to save a few bucks on something if they know that driving is risky, right? Basically, as you get wealthier, the amount of utility you're going to be earning during the time that you're alive is greater, so that makes you willing to pay more for it, and you just have more money, right? So what that means is that a rich person's life is worth more than a poor person's life is, which everybody thinks is just totally scandalous, but it's actually, in some sense, just common sense, in the sense that, so if there's any inequality, right, then some people are going to have more of some things, and other people are going to have less of those things, right? So maybe we object to all inequality, and in fact I think that's quite reasonable that we want to redistribute wealth, and we'll talk more about that later in the course. But given that we have some inequality, shouldn't the poor person be allowed to decide whether they want to live longer but live in a small house, or live shorter but live in a big house? Those are the sort of choices we let people make all the time. And so as long as there's any inequality in some things, there's going to have to be inequality in other things as well, right? So that poor person could probably choose to have as long of a life as the rich person did, but they'd have to spend nothing on anything else. And so as long as they don't end up doing that, what that implies is that the poor person gets less house, they get less car, and they also get less life. So there are basically three categories of things, therefore, that we're going to need to measure in order to measure the value of a human life. So the first is just to get some measurement of how much people are willing to pay to reduce by some probability the chance that they die or are injured in some way. Second, they have to, we have to estimate, the value that they'd be willing to pay to reduce the chance of being injured, not just dying. And the third is that we need to figure out how the value they're willing to pay to avoid those things varies with their income. And basically what's been estimated is that the income elasticity of willingness to pay for life is approximately 0.6 to 0.8. So what that means is that someone who makes $100,000 a year is willing to pay about 1/7 of what someone who makes $1 million a year in order to save their life. That is, their life is worth about 1/7 of the life of someone who makes $1 million a year. Okay. Now, the usual approach to measuring this is that first, we need to make an assumption that people don't care about how they die, they only care about whether they die. The reason that you have to do that, which is, obviously that's a very problematic assumption, but the reason that you have to do that is that otherwise, we're only going to have data on some particular ways in which people die, and we have to be able to extrapolate that to all possible ways people could die. And that requires us basically assuming that people are just as happy to die from asphyxiation as to pass away peacefully in their sleep. So that's a problem. A second thing we need to do is to look for cases where people have made trade-offs. So, for example, deciding whether to take a dangerous job where they, like be a coal miner, where they might die in a coal mining accident, rather than taking a nice job like being in a store or something like that, right? Another example of that might be people decide whether to buy a really safe car like a Volvo, or like a sexier but less safe car like a Porsche, right? Third, we need to figure out how much people were willing to pay for one option versus the other. So we can look, coal miners make $60,000 a year, people with similar skills who go to work in a store make $30,000 a year. That indicates that the person who's just indifferent between being a coal miner and being a store clerk is willing to pay $30,000 a year to avoid the risk associated with being a coal miner, right? But this only measures the willingness to pay of the person who's just indifferent between the two of them, right? Because people who really don't want to die are going to be the store clerks, and they'll be willing to pay a lot more to avoid the accident. The people who are the coal miners presumably value their lives less, and therefore are willing to pay less to avoid the accident. So this only measures the marginal person's willingness to pay. And then, despite what I just said, we have to assume that everybody cares the same amount as the marginal guy does, right? So what I just pointed out is there's a ton of problems with using this approach. But it's sort of all we've got. So even though it's problematic in a lot of ways, the thing that's useful about it is it gives us sort of like a rough ballpark figure that rules out things that are like clearly silly in either direction. So these numbers indicate that sort of a median American values their life at about somewhere on the order of like $5 to $10 million. And so that rules out that like programs that would pay $100 million to save a life are not worth it. And programs that would only cost $100,000 to save a life are clearly worth it. And things in between are much more complicated. But just having that basic ballpark number can rule out a lot of really stupid things in either direction. Yeah.
So you said that there's economic studies that show people will value their lives approximately $500 million.
Yeah.
Does that value change as they get older?
That's a good question. I don't think that anyone's really looked at that, but in principle it should. So I think that people have ways to adjust these things for sort of like the amount of quality adjusted life years you have left. So there's actually a more detailed version of this, which is quality adjusted